Welcome, everybody. My name is Claire Barrett from APIs First, and I'm delighted to be the host for this segment today on data collection basics. And first up, absolutely delighted to have here from Austin, Texas, Anais Dotis-Georgiou, who's joining us from InfluxDB, where she's the lead developer advocate. Anais, welcome. How are you today?
Great. Thank you so much, Claire, for that introduction. And welcome, everybody. As Claire mentioned, I'm a developer advocate at InfluxData. So my job is to represent the community of the company and vice versa. And today we'll be talking about data collection, both using the API within Influx and also other methods. So yeah, thank you so much for sharing my slides.
Fantastic. And I might just get started, invite people to put any comments they'd like into the online chat, which you can see on the side of your screen. And we'll have about 10 minutes or so, 5 to 10 minutes at the end for Anais to answer any questions. So looking forward to it. And over to you, Anais.
Wonderful. Thank you so much. So yeah, today we're going to be talking about data collection basics for InfluxDB. And this is sort of part of InfluxDB University, which is an online learning management platform for InfluxDB. And you can find other talks and courses like this one at InfluxDB University. So it's just a good tool to be aware of if you are interested in InfluxDB. But this talk generally is about mostly about Telegraph, which is database agnostic. So yeah, like I mentioned, it's brought to you by InfluxDB University, which I just wanted to mention. InfluxDB University is where you can get courses on all things, including InfluxDB, Telegraph, which is a collection agent, and so much more. So if you're interested in getting some free courses and earning badges for it, I recommend scanning this QR code and giving it a look. As for today, the agenda, we're going to talk about Telegraph. Telegraph is an open source collection agent for metrics and events. Then we'll look into the plugin ecosystem for Telegraph and how you can leverage it. Then we'll talk about getting started with Telegraph. And then we'll also talk about extending the ecosystem of Telegraph so that if there isn't a plugin that is already available for you, you can really easily take advantage of all the buffering and caching and flushing capabilities that the Telegraph agent has to offer, but extend it in the language of your choice so that you can grab data from whatever source that might be and utilize any APIs that you might want to gather data and write it to a destination of your choice, and as well as do a bunch of other tasks with Telegraph. So before I dive too much into Telegraph, I want to give some background. So Telegraph is one of two products that InfluxData, the creators of InfluxDB, create. And InfluxDB is at the core of our offerings. It's a time series database and visualization platform. And so Telegraph fits into the InfluxDB story in so much as that you can use Telegraph to write your time series metrics to InfluxDB. And what is time series? Well, time series is any data that has a timestamp associated with it. There are usually two types of time series data that we talk about, and that includes metrics. Metrics are data that are written at a regular interval, and irregular time series data is oftentimes known as events. So if we looked in the healthcare space, we might think of maybe monitoring your heart, and your regular heart rate would be considered a time series metric, and something like an arrhythmia would be considered a time series event. Time series data generally exists in really, really huge volumes. If we think about the fintech use case, for example, we have people writing data in nanosecond precision with very, very large dimensionality of their data, maybe, something like 100,000 dimensionality, so very huge volumes. And it's also real time and time sensitive. You need to be able to act on your data in real time. You need to be able to also analyze and transform your data in real time. So this is the characteristics. And InfluxDB is more than just a time series database. It also contains a really powerful API and toolset that allows you to manage everything about InfluxDB. And then it has its time series engine at the core, And last but not least, it's supported by a really massive community and ecosystem. And this is especially true for Telegraf. Most of the plugins that exist for Telegraf have been contributed to by the community, and continue to be maintained and contributed to by the community. So it's just pretty neat to be part of a product that is largely backed entirely by the community. So this is the InfluxData reference architecture, just to give us some more context on data collection for InfluxDB, but also for Telegraf in general. So you can collect data from a variety of different sources. Those sources oftentimes include things like IoT sensors, sensors on a manufacturing floor. We have use cases in the agricultural space, as well as fintech DevOps monitoring and application monitoring. And there are multiple data ingest methods that all utilize the read and write APIs within InfluxDB. So we have Telegraph, which we'll talk about in more detail, but there's also client libraries in a bunch of languages. And with InfluxDB 3.0, it leverages the Apache ecosystem, which includes Apache Arrow and Apache Arrow Flight SQL. Apache Arrow is a in-memory data representation that is columnar, and it's ideal for things like time series data because it enables really fast compression of the data. And it also allows you to leverage Apache Arrow Flight SQL, which is kind of like a next generation API for transferring data that has a lot of advantages over traditional APIs like ODBC and JDCB, because it can really leverage all the benefits of the columnar format that Arrow provides. And it also has a lot of features out of the box, like authentication and parallel data transfer. Yeah, I'll talk more on that in the other talk if you're interested in coming to that. But it's very exciting that you can use Arrow Flight SQL directly if you want to, and client libraries, Telegraph, and there are more options as well. Yeah, and then you can store your data within InfluxDB and use SQL or InfluxQL. InfluxQL is a query language that's SQL-like, that's specific to InfluxDB, but you can also use SQL to, analyze your data and transform your data. And then you can visualize it in a bunch of different analytics and business intelligence tools. That's another advantage of using Flight SQL as the underlying method for data transfer in InfluxDB, is that it enables connection with JDCB and ODCB drivers, which means that there's now interoperability with tools like Power BI and Tableau. So you can visualize your tools there, or also things like Apache Superset or Grafana. But now let's actually talk about Telegraph so we can learn how we can collect data with Telegraph. So there are a lot of different data collection options. Telegraph itself is open source, like I said. It has over 300 plugins, and there's a regular cadence of releases. And you might want to use Telegraph because it's a no-code solution. You can configure it through a single TOML configuration file. It has that large community backing, so if you have any questions about plugins or how to configure it, you're going to get answers. It's extremely lightweight, but that being said, you can even have the option to reduce the binary size further by building a Telegraph agent with only the plugins that you're actually going to be utilizing. And so you can make it really, really lightweight, and that's especially useful in a distributed architecture where you want to, maybe run Telegraph in a container and you're running multiple Telegraph containers that are getting sources from a variety of different places, and you just want to reduce the size as much as possible. So yeah, essentially Telegraph is extremely configurable. There's also a bunch of client libraries. There are quite a few for InfluxDB 3.0, including Python, C#, Java, Go, JavaScript. Might be missing a few. There's 12 total libraries for previous versions of Influx as well. And it handles things like batching and chunking and setting the right headers. And it's a great way to get started using InfluxDB in the language of your choice that you're already familiar with. Also, in the OSS version, there are scrapers as well that you can use to scrape Prometheus metrics. There's also Flux, which is a query language for the open source version that allows you to pull data from a variety of different sources, things like CSV with a CSV from function. You can make HTTP calls directly with Flux as well. And there's a lot of other options there. And then there's also native ecosystem support as well. So there's different sources that speak line protocol, which is the ingest format for InfluxDB. And so, there's support for things like FluentD and Vector and JMeter. But the reason why you might want to use Telegraph in particular is that instead of having to write really long data scraping scripts or worry about unrelated data collection or worry about scaling your data collection or worry about things like if you have connection loss or messy data, Telegraph provides solutions to all these common problems. So yeah, it's low code or no code. It has a robust scheduler. It supports really high speed ingestion. It has metrics routing as well as flexible parsing and formatting. There's also, it contains a buffer so that if any of your services go offline for a while, it'll store those metrics and write it when it's available again. And then it's customizable through the execd plugins and the Starlight plugins that allow you to, extend the capabilities and customize it even further. And for InfluxDB, it leverages, the write and read APIs if you're writing there, but you can leverage like any sort of APIs that you want when you are using the exec plugins and you're writing your own or extending the functionality of Telegraph to write your own plugins, or you'll notice that a lot of the other plugins use APIs as well. So essentially, it's also written in Go, and it's downloadable as a single binary with no external dependencies. Has a minimal memory footprint that you can reduce even further if you decide to just include the plugins that you want to use. And it's optimized for writing to InfluxDB, but it's definitely database agnostic. And it is optimized for streaming data. It collects data on an interval and flushes data on an interval and writes data at an interval. And there are a bunch of different plugins. Some include HTTP, AWS Kinesis, GCP PubSub, plugins for Kubernetes and Docker, for Kafka. We've even got Fortnite plugins and Minecraft plugins and all sorts of different plugins. So really, if you have the task of collecting data and writing it to a data source, highly recommend looking into Telegraph. So let's talk about the scheduler a little bit more. There exists adjustments for clock drift, as well as adjustments for job scheduling issues that may occur. So you can do things like also specify, I want regardless on when I start my Telegraph agent, I want to make sure that the collection interval always happens at the top of every 5 seconds, starting at the top of every hour, for example. There are in-memory metric buffers. So like I mentioned, if your service goes offline, it will continue to collect the data and store it in a buffer and write it when you get back online. And there's metric tracking with flow back pressures in plugins like the Kafka plugin. Full streaming support. There are metric routing as well that allows you to drop names or fields and pass certain ones so that if you don't need to collect all the metrics and write all the metrics, you can do so. And then there are a bunch of processor and aggregator plugins that allow you to do things like serialize your data and format it in a particular way, or even parse your data. So let's talk some more about the plugin support. So the breakdown for the Telegraph plugins ecosystem contains 4 parts. The first is the input plugins, and input plugins collect metrics from the system, services, or third-party APIs. There are processor plugins that transform, decorate, or filter metrics. Aggregator plugins will create aggregate metrics, things like mean, min, max, quantiles, histograms, etc. And output plugins will write metrics to various destinations. And new plugins are designed to be easy to contribute to, and pull requests are welcome at any time. And we work to incorporate as many pull requests as possible. So if you're looking for something to contribute to, I highly recommend taking a look at Telegraph because it's quite easy to contribute to, especially external plugins, which I'll talk about in a second. And let's look at the breakdown of these type of plugins. So there's over 200 input plugins, over 25 processor plugins, over 5 aggregator plugins, and over 50 output plugins. So yeah, you most certainly don't have to write to InfluxDB to take advantage of Telegraph. And here are examples of some of the input plugins that come from, your system, services, or third-party APIs. We have metrics from a lot of common open source data infrastructure, things like MySQL, Cassandra, Redis, MongoDB is on there, ActiveMQ, RabbitMQ, Aerospike. We have metrics from common DevOps tools and frameworks, things like Jenkins, GitHub, Nginx, HAProxy, Kubernetes, etc. And then we have plugins for monitoring systems, things like CloudWatch, Prometheus, Google Monitoring, and more. And then we have low-level OS system telemetry, things like Linux sysctl, FSNstat, and others. Here's the continued list if you want to take a second to look at that. I guess there's also worth mentioning that Telegraph can ingest data from very many generic data sources. Like the file plugin allows you to consume the contents of entire file. The tail plugin does very similar thing to the file plugin, except it lets you actually tail a file, which can be quite useful. We have the socket listener, which receives input from socket over TCP and UDP. We have the HTTP listener, which receives post requests over HTTP. And then we have the exec plugin, which executes a process and then gets metrics from standard out, and that is extensible in any language of your choice. And the execd plugin, which is what actually executes that demonized process. And then, yeah, even more plugins. You can also ingest line protocol directly. You can ingest CSV, you can ingest Grok, JSON, all sorts of different inputs are allowed. And so now let's take a look at some of the processor plugins. Processor plugins are used to transform, decorate, and or filter metrics. So we have like the regex plugin, for example, that you can use to use regex to decorate or transform. execd processor plugin, I've actually used that to collect mini batches of data within Telegraph, and then as I collect those mini batches, leverage the execd processor plugin to generate micro forecasts, and then continuously write those micro forecasts to InfluxDB so that I could actually perform the forecasting with the agent itself, and then alert on when like temperature values were exceeding a certain value threshold, so that I know that I could go ahead and adjust the system that I was monitoring. Yeah, and then we have the Starlark plugin as well, which is pretty useful for performing all sorts of math on your metrics. And then we have aggregator plugins, and aggregator plugins will create aggregated metrics. So we have min max, we have value counter, histogram, basic stats. Those ones are pretty self-explanatory. Last but not least, we have output plugins that allow you to write data to a variety of different destinations. You can specify multiple outputs to dual write to data to places in parallel. Just wanted to illustrate that while you can write to InfluxDB, you can write to a bunch of different other platforms as well. So yeah, essentially everything we talked about on the previous slides is kind of consolidated here. But essentially, Telegraph is designed to interface best with InfluxDB, but can interface with a bunch of different outputs and can dual write to multiple outputs as well. And this is what Telegraph could look like. You have multiple input plugins and can be performing processing and aggregating on specific inputs and measurements. And then you have multiple output plugins as well, and you're writing those to different sources, whether that's InfluxDB, Kafka, or CloudWatch, for example. And if you can't find the plugin you need, even though there are hundreds available, we 100% recommend or encourage that you go ahead and write your own. there's a strong community of contributors that can help you, and there's good documentation on getting started. You just want to follow the Go contribution guide. And then you can also decide to write any plugin that you might want and run it externally with the execd input plugin or processor or aggregator or output plugins. So yeah, it just makes Telegraph extensible in your language, and it essentially reads metrics from standard in or standard out and leverages standard in or standard out. And then you just have to apply your custom script to the metrics coming in through standard out and make sure they standard in and make sure they come out through standard out in the appropriate form. So for InfluxDB, you'd want your metrics to come out in standard out. One second. Pardon me. In the correct format. And so for InfluxDB, for example, that would be line protocol. So now let's talk about actually getting started with Telegraph so that we can leverage it. So the first thing that you'd want to do is go to influxdata.com/downloads and actually go ahead and download Telegraph. And you can find an installation guide that is right for you. And then you'd actually want to start configuring it. So let's talk about some of the configuration basics. So this is what the TOML configuration looks like. It's easily configurable. It's like filling out a form. And as you can see, you have multiple plugins per Telegraph instance. So you'll normally have one Telegraph per device though. So depending on your architecture, you may have thousands of Telegraphs with only one or two plugins, or you might be a hobbyist and you have one Telegraph with multiple plugins. But you would, for example, in the left-hand screenshot, we are using the CPU input plugin, and you can decide, if you want to collect things like the total CPU and also decide, we're also using the disk input plugin and seeing if we want to ignore mount points by file system types that we've included there. Yeah. And then on the right-hand side, we have an example of the Kubernetes input plugin where we'd specify the URL for the for kubelet, and we have a bunch of different options that we can include to whether or not we want to exclude or include pod labels, for example, whether we want to set a response timeout, and there's other optional TLS configuration options as well. So what exactly all is in a Telegraph configuration file? The default configuration is quite long, but that's because it includes setup for the Telegraph agent, and that includes things like the collection interval, right, which is how frequently do we want to be collecting data from our source, the jitter interval, which determines how we want to load balance data and send it to our output, buffer and batch size. So how much data do we want to send at a time, and how much data do we want to save in memory if there are issues that are encountered and services are offline. Then we have global tags, and those are tags that can be added to all metrics collected from all inputs. Then we have enabled outputs and processors and aggregators and inputs and their respective configurations. So that's why the default configuration is so long. But you don't need to use the whole config file. You can generate a config file with flags that point to the specific plugins that you are interested in using, and you'll reduce that config file by quite a bit. And so now I'm going to take a second to give a little demo on how to go ahead and use Telegraph and InfluxDB together. So let me share my different screen. So hopefully now you all can see. Yes, you can. Excellent. So this is what InfluxDB Cloud looks like. So real quick, just wanted to walk you through the homepage. You can add data here, and you can see that we can go ahead and configure agent, or we can use the API directly and view the API docs, or we can select a programming language, and it will actually walk us through a guide of getting started with a client library, including installing dependencies, generating tokens, which it'll do for you, initializing your client, writing data, and it'll show you the example data, and querying your data as well. So that's a really useful tool, I find. But today we'll focus on the Telegraf agent specifically. So we'll go and say configure agent. And first, but not last, we actually want to create a bucket. Maybe we'll just call it today. And we set a retention policy, which determines how long we want to store our data for. And then after that retention policy expires, then our data will automatically be expired. And that's just a kind of a typical component of any time series data management, because you're usually only interested in retaining time series data that's recent, and historical time series data usually doesn't become valuable after a certain point. So yeah, we'll just call our bucket today. And then we'll go over to Telegraf and we'll create a configuration. And here we can choose a bucket that we want to write to. Let's write it to our bucket for today. And let's just do something simple like look at CPU metrics. So we can click on the plugins that we want to use. We could click on whichever ones we want and also browse them here. So we can see, a large list of all the input plugins. But yeah, we've selected CPU, so we will continue configuring. We can name our configuration. And then we're given our input toml config file, and we can just leave the defaults as we want, but we can see some of the options that are available for this Telegraf plugin, which include things like deciding whether or not we want to report per CPU, which we do, if we want to report the total system, CPU, etc. And so then we will scroll down and we'll say save and test. And automatically it'll generate a token for us. And once we've already installed Telegraf, we can go ahead and just copy and paste that into our terminal, which I won't show. And then we can copy and paste the actual command that points the Telegraf agent to the config that is generated here. And then once that gets started, we can see, and you can't see this right now because I'm just looking at my terminal, but essentially once you start the Telegraf service, it'll say that the Telegraf service is started. It'll list the plugins that are available as a part of the config that you provided. It'll show you which Telegraf plugins you have loaded, give you a full list of all of the ones that you have. In this case, it's only the CPU plugin and the output plugin for InfluxDB. And then we can say listen for data. I have a feeling I'm not getting an error on the Telegraf agent, so I have a feeling that this is just a little bug within the UI real quick, because let's actually click on our bucket and see if we can see data. So we can go ahead and use this SQL sync to generate data for us. But we can see that we have a CPU measurement, which means that we in fact did correctly write data to InfluxDB, and we can go ahead and visualize it and automatically generate that SQL query for us and see all of our data. And we can also search the results here, which I find pretty useful. And then you just query data as you normally would with SQL. So yeah, with that, let me continue. So now that we have a feel for what Telegraf is and what it feels like to use it, I want to talk about extending the ecosystem. So you can extend Telegraf by either contributing plugins yourself, submitting upgrades and enhancements to existing plugins, or use the execd to write a plugin in Go or any language of your choice. And also want to talk about the Starlark processor plugin a little bit more. What that does is it calls a Starlark function for each match metrics and allows for custom programmatic metric processing. So people use it for things like math operations, string operations, renaming tags, and logic operations. And the execd plugins are very cool, and you can actually contribute an external plugin. We have a collection of external plugins that are all execd plugins. And essentially what you can do there is The way it works is that an execd plugin runs their own process as a daemon. And it's a great way to utilize the Telegraph agent features and avoid the need for review by the Telegraph team or inclusion in the official Telegraph repository, but you can contribute to the external Telegraph repo. And it supports the same API as the internal plugin and can be used both for Go and non-Go plugins. So it's a great option if you want to write a plugin in a language other than Go. I've written one in Python, but people have written ones in all sorts of languages. And execd can be used for licensed software plugins as a result, and it can be used for any type of plugin, input, output, processor, or aggregator. So this is the execd plugin architecture for each type of plugin. It visualizes the setup of the execd running as a plugin within the Telegraph. And as you can see, it communicates with the external binary over standard in and standard out, and it uses line protocol to do so. And in the case of the input plugin, execd input reads the line protocol metrics coming from standard out. So to write an execd input plugin, you'd want to start your process and write your metrics to standard out. For the processor plugin, it sends the metrics to your process, and then your process is parsing that, modifying it to whatever you need, and then you serialize it back to line protocol and then write it to standard out. And that's the same thing for the aggregator plugin. And then for the case of the output plugins, Telegraph writes the metrics using standard in, and then you're writing them to an external service. And some people are always curious about like what are some of the programming or performance, sorry, we talked about some of the programming differences, but what are some of the performance differences with execd as opposed to other plugins within the binary? Because it is streaming, the total time to go through the processor is fairly quick. It does depend on what you're doing, though, of course. If you some of the analysis or processing that you're doing is extremely computationally heavy, then obviously it will take longer. But generally, the throughput is as good and very similar to a plugin that is part of the binary. So you can relax. And yeah, and last but not least, I wanted to spend a little bit of time talking about the community and share some quotes from customers who are really excited about the Telegraph community. It's referred to as a Swiss Army knife of collection. People are collecting from MQTT and OPC UA. Wayfair takes advantage of the Kafka and Telegraph streaming service to create a more robust data topology. So yeah, we have a lot of people that are fans of Telegraph. People doing really cool things with it, especially in the open source community. So yeah, in order to get involved with Telegraph, you can visit github.com/influxdata/telegraph. We also have a community Slack with the channels Telegraph, where you can ask any questions about Telegraph, and Telegraf Dev if you're interested in talking to the developers directly or are developing your own Telegraph plugin and you want help there as well. And then our company website is community.influxdata.com. That's where our forums are. So if you have any questions, you can write there as well. And then I just wanted to include a quick side note. InfluxDB Cloud is now powered by IOX, or our 3.0 storage engine. And like I mentioned, it's built on top of the Apache Arrow, the Apache ecosystem, which includes Apache Arrow, Apache Parquet, Apache FlightSQL, and Apache Data Fusion. And so while some of the APIs are changing, it has the same ingest method as all the previous methods of InfluxDB. So everything in this talk still applies. So there's no concern there. And then here are some references that could be useful for you. This is the last link is the external plugins guide that can walk you through contributing an external plugin. And also you can see the full list that people have contributed to already. I think they're really cool. So worth giving it a look at. And then some more community resources. We have our Slack, we have our forums, our docs are phenomenal. And again, InfluxDB University, you can take courses on Telegraph specifically if you want to. And then once you've completed them, you can get a badge that you can share on your LinkedIn. So that's a cool perk of that as well. And yeah, you feel free to go to influxdbu.com or scan this QR code. Thank you so much, everyone. I will see if there are any questions. But otherwise, I will stop sharing my screen, and I so much appreciate you coming to this talk.
Thank you, Anais. That was fantastic to get such a comprehensive update on way.
Oh,
It's fantastic. We don't have.
seems that I've lost her, so I think she said that there are no questions.
There we go. Yes.
Hello.
Sorry. Hi. So yes, Anais, there are no questions at the moment. At the moment, but I'm curious to hear from you in terms of mentioned at the end that you have the Academy certification process that is popular. Who are the sorts of people that are choosing? You mentioned early on it's a very no-code environment. I'm curious about the sorts of personas, types of people who are taking advantage of this and how that's helping them.
Sure. Yeah, all sorts of people. We have people within organizations that are wanting to become trained on InfluxDB and Telegraph that are taking the certifications, but we also have a bunch of hobbyists. InfluxDB, since we offer OSS versions of InfluxDB and Telegraph, is completely open source. We have a lot of hobbyists. People are monitoring things like their barbecue. They're doing all sorts of home automation. We have I met one person recently in the community who was creating their own chlorine solution for their pool to manage the chlorine levels in their pool that would automatically, uh, use a sensor to measure those values and then pour more chlorine as needed, which I thought was a cool project. There's another person in the open source community who's monitoring um, uh, birds of prey and endangered birds of prey in the UK, and using InfluxDB for that. So it really just depends. We have people in professional settings and also just hobbyists that are looking to leverage the technology and want and enjoy learning in that style. Some people just prefer to use docs and read everything or find example repositories and learn that way. But some people really appreciate the structure of a learning management solution like InfluxDBU. So it kind of just depends on people's individual learning preferences.
Oh, that's really really interesting. And some of the other end of the scale from your hobbyist communities, you've got many large and household name client customers and those sorts of things. What are some of the examples that you yourself have been involved in or supported that you think are some of the best showcases of getting value from InfluxDB?
Sure. One of my favorite use cases is Bbox. Bbox is a company that delivers solar panel energy to communities that are developing and also largely off grid. And so they use InfluxDB to monitor all sorts of solar panels. We also um, uh, in CERN uses InfluxDB to monitor their particle accelerator, and so that's a really cool use case that I enjoy as well. We have a variety of um, agricultural use cases. People are monitoring things like Spio. It's another company that uses InfluxDB to monitor all of their living walls. We have another small farm out in New York that is a an indoor farm, and they use InfluxDB to monitor all of their farming efforts and make sure that they can produce their highest yields. So yeah, there's a bunch of different use cases. I think some of my personal favorites are ones where technology is being used in conjunction with the physical world in various IoT cases. Because I just like that blend of nature and technology coming together. So.
I mean, these examples are just, they illustrate the kind of explosion in creativity that's coming out of data connectivity. Of course, the other I'd be curious to hear how the last, sort of 6-12 months of explosion in generative AI use cases have started changing on the other end of the data journey for your customers. What impact that's had on your organization and teams?
I think it's had an impact in so much as that we've really recognized that we need to be able to provide interoperability with a bunch of different tools so that people can go ahead and leverage those capabilities. We're not trying to reinvent the wheel and add machine learning capabilities to our platform because they already exist and they're already so good. So that was a huge reason why we rewrote the storage engine for 3.0 under the Apache ecosystem, was to provide that interoperability with business analytics tools, with and business intelligence tools, and be able to transfer data really easily with Aeroflight SQL, and also extract Parquet files directly as well, so that developers can go ahead and leverage those tools. And then on a personal level, I guess it's changed just the way we work now, right? Like we do use ChatGPT, all of our developers do, and just kind of, it's nice. It speeds up the process and allows you to kind of rubber duck with something that provides useful feedback. So it's made my job more interesting because I spend more time, I think, working on the creative parts of my job rather than some of the more mundane parts, I would say. So.
And do you find that people who are maybe not in the tech industry, that you are curious to hear how that is making a difference in a positive way, given how much sort of publicity that largely have a lot of scare tactics as well as optimism?
Yeah.
How do you find those conversations?
That's such a challenging conversation. I really appreciated Naomi Klein wrote an article a few weeks ago that I really appreciated her, and she was very much like warning about some of the disadvantages of it. But I also see really sweet examples as well where people are using it in very inspiring and optimistic and beautiful ways. So I think time will tell, and but I do agree. I think taking time to evaluate any necessary regulation would be a very good move.
And we've moved off from best practices with data collection, but we are going to need to probably wrap up fairly shortly. And I can't see that there are any other questions in the chat, so we've got to maybe some people I'm sure that have been enjoying the conversation, but not burning with the question, but you've given us a lot of information and more that you can find out from the website. Certainly on behalf of API Days and the community at large, we're really grateful for InfluxDB's gold sponsorship role in the conference at Interface this year. So, and thank you for making the time to fly in from remotely to join and share all of your knowledge and experience.
Thank you so much, Claire.
Thank you very much, Annie.